Hello, my name is Christian Frank, and this is my project for ECE 376 Embedded Systems, homework set number 5. For this lab assignment, we are supposed to write a program that uses either a keypad for inputs from the user or a stepper motor for outputs. However, I decided to write a program that utilizes both. The title of my program is Degree Indicator, as you can see on the display, and it is just that. It indicates the number of degrees that the user wants. In this case, degrees is not temperature degrees, but as in rotational degrees, 0 to 360. The user enters in their degrees on the display. On the keypad, the display will indicate the number of degrees that the user enters here. Then, when the user pushes the pound symbol, which serves as the enter for this program, then the main part of the program will begin. On the display, it will still tell the user the number of degrees they wrote here, and over here it'll tell the current number of degrees that the stepper motor is at, which brings us to the stepper motor. The stepper motor will turn however many degrees the user entered to match that angle, anywhere between 0 to 359 degrees. If it goes above 360 degrees, then up top it will tell the number of additional rotations are needed for you to match. So then you can add the results, the number of full rotations plus the current angle, and it goes only to the current angle, this number down here, which is anything less than 360 degrees. It will modulate accordingly. For my program, I also included the star button, which serves as minus, so the program will also take in negative degree numbers. If you enter in a negative degree, the stepper motor will rotate the opposite. So in full functionality, the stepper motor will rotate between minus 359 degrees and positive 359 degrees. And then anything above that will be displayed as additional rotations up here. The additional rotations will also write a negative as appropriate, as well as the output will be negative, however it is appropriate. Over on the side, I included 2 of these buttons as well. If the user enters in a wrong digit, then they can press RB1 button, which serves as a backspace, so it clears the last digit, allowing the user to re-enter the digit. This is just a lot more helpful for the user interface, so anytime you accidentally press a button twice or put in any wrong answer, instead of having to enter it and then let the program run to the wrong angle and then re-enter the number, you can just simply quickly backspace the last character that was entered in wrong and re-enter in the number correctly. In addition, I added RB0 button, which is a hard reset of the whole program. So wherever the program is at here, if you press the RB0 button, it will completely reset the whole program, meaning the stepper motor, wherever it is currently at, it will rotate all the way back to the 0 position. Also, the display, it will show on the display 0 here. The current degree mark will be returning to 0 at the same time as the stepper motors, you will see. And then as soon as it hits 0, it will return here to the title screen, just showing you the name of the title. So now, one last thing before starting to show how the program works, to show the hardware. In order to implement the stepper motor, I import it onto an H bridge and the outputs of port A. So port A is output. Each of the digits here light up as well, and as they light up, the symbols represent the wires turning positive on our H bridge, which then correspondingly outputs through these wires to our stepper motor and rotates the stepper motor accordingly. Port C is the input from the keypad, and as you input a number, you will occasionally have a light come up on port C as well. So, let's begin. So for starters, if I wanted to enter in the number 90, if I press 9, here you see bit 4 lit up on port C, so that's saying it read it. And as soon as I release it, a 9 appears on the screen. So the number appears on the screen as you are currently entering it, which helps the user to make sure that they know what is the number that they are entering in. If I press 1, accidentally, I wanted 90, but I accidentally hit 91. Again, it shows up on the screen. I can hit the backspace button, RB1, and it clears the last digit. So now I can re-enter in the number that I was actually wanting. So I enter in a 0 now. In this case, port C 3 lit up, indicating that it read 0, and the 0 pops up. So here, the backspace is working appropriately, and it keeps clearing back. And here you have each of these digits working, reading each of the ones. So anything on the right column that you push, it'll light up the 6th bit on there. Anything in the second column will light up the 5th bit. Anything in the third column will light up the 4th bit. Or rows, row-wise. It's reading rows. So it'll tell you what rows you are pushing in. And how the keypad works is these outputs here are outputting a positive signal into the keypad, reading each of the columns, and then each of the rows are being inputted into the board. And if you have a column and a row with a 1 at the same time, then it knows which one is being currently entered in. In addition to that, we will see the stepper motor now rotate. So if I enter in the 90 and I push the pound for starting, the stepper motor now rotates to 90 degrees, as you can see. I can enter in 180, and it rotates to 180, 270, back to 0 degrees. And from here I can even go to minus 90 degrees by using the pound symbol. Each time you use the star, it changes the sign. So you can swap, it always negates it, so you can go to minus 90 degrees and it will rotate accordingly the opposite direction as it is supposed to. So you can go to minus 270 and it is working appropriately. Now, in addition, while the stepper motor is changing, after the number before the colon is the number entered by the user. So I can enter in 90, and it will show that that number is being updated as I write to that port, constantly being updated. The second number after the colon, that is the current number that the stepper motor is at. So as we rotate the stepper motor, you'll see this number changing at the same time. And there we see the output is 90. So it tells you what the current degrees that the stepper motor is at. So the user can see that it is actually turning as well at the same time and see the actual action of the stepper motor in process. So there you go. 270. And back to 0. Should be noted that on the video there appears to be a small delay. However, that delay is more on the video. It's not in person. So actually looking between the stepper motor and the LCD, the two appear to be turning on, starting the rotation and stopping the rotation to whatever degree they're going at the same time. To the naked eye, it is unnoticeable difference between the two. So they appear to be synchronous. Finally, on the top we have the number of rotations, as you can see. So if we enter in anything like 360 and above, if we enter in 360 degrees, it's currently at 0. It will not rotate. It will stay at that. However, the rotations will up to 1. Saying 1 full rotation plus an additional 1 full rotation plus an additional 0 degrees equals 360 degrees. If I enter in 720, it will up it to 2. 2 full rotations plus 0 degrees is 720. If I put it at 540, then we will see it rotates, and voila! 1 full rotation, which is 360 degrees, plus an additional 180 degrees, which the stepper motor goes to, will give you your 540 degrees. So this in general just can tell you if you have some number of degrees above 360, you can find out just on a scale between 0 and 360 where the position will be at, plus how many full rotations it will complete. So for example, if you're thinking of a car rotating, you will know that the car will rotate a complete rotation, and then it will also go an additional 180 degrees, so the top of the tire will then be pointing downward instead of upward like it was before. It also works for negative numbers, so if I put in a negative 540, it rotates accordingly, and sure enough, you have minus 1 full rotation plus an additional minus 180 degrees gives you minus 540. And as you saw, the stepper motor went all the way around to minus 180. So to show the full length of the stepper motor again, it goes to minus 359 because minus 360 minus 360 won't rotate, it'll just show a minus 1. And a plus 360 won't rotate at all, it'll be just a plus 1 rotations, but 0 degrees. So the full rotation that the stepper motor itself does is it goes to minus 359 degrees, and it will rotate all the way from a minus 359 degrees, which is not quite distinguishable from 0, but is slightly to the right from the 0 position. And it will go from here all the way to a positive 359 degrees. Not reach 0, all the way around to there, where it's just slightly left of the 0 degree mark. That is the full rotation that the stepper motor will do. The full span of how the stepper motor itself rotates, as well as the full span of what numbers appear in this slot here. Finally, the last key button was the reset, as I said. When you press it, this will reset to 0, this will be 0, this number, along with the stepper motor, will change at the same time to reach 0, and as soon as it's 0, the program will return to the title screen. So here it's a nice little return to the title screen again, showing you this is what the program is. So if you're any time within the program, you can return back to the title. As soon as you enter in, it starts showing again, and then as soon as you enter in a number, it starts showing that number, and then as soon as you hit the enter button, it turns to the actual results format where it shows rotations, current degree entered, and degree entered and current degree of the stepper motor. And it stays on the screen again, allowing you to interact with it until you hit the clear button or the reset button, and once again resets all the way back to 0 and the title screen. So there you have it. That is my degree indicator program, as I have called it, which utilizes both a keypad for inputs from the user and a stepper motor for outputs. Thank you very much.